is pretty quick. It'll be the last of the problems. So 43 to 50 is section 2.5 in the assignment for chapter 2 homework. And then right here is just talking about interpreting graphs. In other words, what they're giving us here is some beware information. So some things to watch out for and stuff like that. So nothing crazy here, just some extra tidbits about watching how you interpret graphs. Okay, so some things to beware when looking at graphs. So one, they want to make sure that you are making the appropriate display. And so that's kind of a big piece in section 2.5 where, if you have numerical data, make sure that you are doing a numerical data display like a dot plot or a stem and leaf plot or a histogram or a frequency table, something along those lines. Make sure that you are using the correct one. If you have categorical data, then make sure that you're either using the pie chart or the bar graph, which the bar graph is the best overall anyway for a categorical. So make sure that you have the appropriate display for the appropriate kind of data you have. Numerical data uses numerical displays. Categorical data uses categorical displays. So that's the first thing. 2, watch for a change of scale on the vertical axis, so the y-axis. Watch that they, make sure that it is comparing apples to apples when it comes to that. If you have a y-axis scale that starts at 0 and goes up to 10, but then on the other one, it has a y-axis scale that starts at 5 and goes up to 10. What they have done is they have zoomed in. So be careful of that. Make sure the y-axis scales are matching apples to apples. Okay. And then finally, sometimes when it comes to categorical data, they will compare relative size of objects. Okay. Versus the height of the object. So they won't take objects, and you'll see it soon enough. Like one piece I saw was a television. Okay, this was an example in college mathematics. They had a big television, and then as it went throughout the years, the television got smaller and smaller and smaller. And people are misled by that information because the television, even though it's the same picture for everything, kept getting smaller and smaller. And so they're seeing much more of a change between year to year than what might actually be happening. Okay, so these are kind of some of the things that you're going to have to look out for. And I'm going to show you examples of these here in just a second. The other thing in 2.5 that they want to talk about is that because of technology, they're talking about the future here. And this isn't really a beware, but it's where things are going. Because of technology, computers and technology have helped us evolve further to make more interesting types of graphs and different things like that. So technology is a huge help to us as statisticians moving forward. So that's kind of really what 2.5 is about. So let's take a look at some things. So right here is a graph. Okay, violent crimes, the years. Notice a nice big change here, right? Okay, I'm going to show you that same graph. Here's that same graph. Does it really look like there's been that big of a change? No. What's the difference? This is a more accurate graph of what's going on, where this graph up here is misleading. What's going on? Why is this graph that's up here at top misleading versus the one down here? Well, hopefully you notice that, the bars are different. This is what I was talking about with that vertical y-axis. Make sure that things are, kind of where they should be. Okay, because this guy starts at 1.2 and goes up to 1.4. This one actually starts at 0. So here it looks like there's big drastic changes in the violent crimes, like it's gone down a lot. But if you really look at it, has it really gone down a lot? I wouldn't say a lot, but it's definitely gone down. Okay, so again, watch out for things like that. This is a y-axis change. And then this one right here, this is what I was talking about, that size change. See how the house has gone and gotten smaller, okay? But what you should really be looking at is the height of the box. The heights of the box are really how much change there has been, okay? So really, there's not much change that has happened. But because the house is getting smaller, you think that, oh, there's a lot of change that's going on because this is a big house and this one is even smaller. So that's what I was talking about, comparing the relative size of the objects. This is not to scale. Okay? So those are what I was talking about in the beware. So let's take a look at some of the homework that you're going to see. Okay? So here is a problem that you're going to see. It says a student has gathered data on self-perceived body image where 1 represents underweight, 2 represents right, 3 represents overweight. A graph of the data is shown. What type of graph would be a better choice to display this data and why? So the first thing you need to know is what kind of graph is this? And then what type of graph would be a better choice? Because this is a misleading graph. Go ahead, think about it, and then we'll talk about it in a second. Okay. So if you look at this data, they've just done a little bit of coding up here. This is actually categorical data. But what do we have right here? This is a histogram. Okay, the bars are touching. You've got your numbers here, which could bleed into each other. It's misleading. Okay, they made a histogram. What type of graph would be a better choice of this? Because this is categorical, we need to make a bar graph where these bars are not touching. Okay, this is a histogram. When those bars touch, you're really displaying, and you got numbers down here, you're really talking about a histogram. And histograms are for numerical data, not categorical. Okay, so these are the kind of questions that they're going to be asking you. Again, it'll be nice and multiple choice down below it. All right. So here we have the pie chart reports the number of hours of sleep last night for 118 college students. Okay. What would be a better type of graph for displaying these data? Explain why the pie chart is hard to interpret. Okay, so 2 parts. Why is this pie chart bad? Why is it hard to read? And then the other one is, what would be a better type of graph? And go ahead, think about it, and then we'll talk about it. Okay, so hopefully when looking at this, you can see the reason why this is. Let's tackle the why this pie chart is bad anyway. You have way too many categories going on. You have a lot of stuff going on, and you really have to make sure that you read all this information over here. This is just a giant mess. Okay, it's hard to read. It's hard to know which one is better than the others, things like that. So looking at this, since we're talking about the number of hours slept, that's very numerical in nature. They chose a categorical data or a categorical display right here. This would be better if we maybe did a histogram, because all of these could bleed into each other, and we could figure out where to put the 5.5. Does it go into a certain column and things like that? So a histogram would have been a better display of this, because we're working with numerical data, okay, not categorical. Okay, this person put categories here because these are probably the different answers he got, but it's really numerical because you can count up how many hours you slept. That's a measure. Okay, and I think this is my last one. Yeah, so this is the last one. So down here it says, refer to the accompanying bar chart, which shows the time spent on a typical day talking on a cell phone for some men and women. Each person was asked to choose the one of 4 intervals that best fitted the amount of time they spent on the phone. For example, 0 to 4 hours, 12 or more hours. Okay, so go ahead and think about these questions, pause the video, give them a shot, and then we will talk about what's going on. Okay, so it says identify the two variables, then state whether they are categorical or numerical. So this is kind of taking everything that we know. So the two variables that we are working with are gender, so male and female. That's definitely categorical. Okay. The other one that you're working with are these four intervals. Now, I know counting up the number of hours you talk is numerical, but because they have made intervals here, this has now made it categorical. That's why I wanted to talk about this one. The answers that people are going to come up with, like, say, I talk for 3 hours, they definitely are counting that up. That's measured. But because we have intervals here that you have to choose from, we have now made it categorical. Do you fall in the category of 0 to 4? Or do you fall in the category of 12 or more? Okay. So both of these are categorical. All right. I hope that makes sense. Okay. So down below, is the graph a bar chart or a histogram? Which would be better choice for this data? Well, down below, if you look at this, this is definitely a bar chart. This is the best graph for this because our data is categorical. Okay. So this graph that we have down below is great. I would not use a histogram because, again, our data is categorical, not numerical. Okay. So part C says if you had the actual number of hours for each person rather than just an interval, which type of graph would you use to display the distribution of the actual numbers? Now, on this question, this is where we would use the histogram because if we had the actual numbers for each person, that's the measurement, that's numerical. That's where I would use a histogram. And I would probably break it up and do two histograms, one with female and one with male. So I would have two different histograms there. Okay. All right. So last but not least, it says compare the modes of the two distributions and interpret what you discover. What does this say about the difference between men's and women's cell phone usage? So if we look for the mode for the males is 0 to 4 hours. The mode for the women is 4 to 8 hours. So what does that say? It says that men talk less on the phone than women. Okay? And there we go. That's what section 2.5 is about. You know, talking about the appropriateness of the display, watching out for those bewares. And now you know all of chapter 2. So you have 43 to 50 to finish up for section 2.5. And that's it. Talk to you later.